It's even more than obscurity. It's the fact that at a certain level the information is not even there, right? Yeah.
And it's also the probability of a single disk failure.
Yeah. That's I wonder what the number is. You maybe just think about something. I wonder how many drives we lose a day. I don't know. Probably a lot, given the number of like, for example, I think there's over 130 billion objects in Amazon S3 right now. So you got to think about the number of drives it takes to store all that.
Do you prefer the question as we go, or should
I'm totally okay like this, guys. I'm just the one on the stage with the PowerPoint, right? I like this kind of format. Yeah. Okay, I'm going to talk about encryption a little bit, right? So let's just kind of hang off on that for a bit. Now, at the instance level, we use Zen. That is our hypervisor. And there's just a couple interesting things about our implementation of Zen that I think you might find kind of interesting. Our administrators, of course, can manage the physical machines. All of that is done remotely, and that's done via SSH, so that we've got some degree of protection. We know who that person is. We know where they're coming from. You, as the customer, have complete control of the VM. So when you start a VM, you choose what operating system you want to run, and then from there, we don't have access to that stuff anymore. We don't look into what's happening in the memory. We don't know what operating system you're running. We don't know whether you are or are not violating the license of the application that you install. We hope that you're not violating the license of that. But we're very, very clear about data belonging to you and your VMs belonging to you, and that we have a high degree of procedural as well as technical isolation between our operators and what you're doing. Yep. 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 Okay, so I want to talk about that a little bit, right? So this is the question that people always seem to really like to ask, right? What are you doing to isolate one virtual machine from another? So we've got this concept called security groups, which is one way. This is one of many elements that we use to isolate VMs. Now, I said that we use Zen, and we add some customizations to Zen. This is the most important customization that we add. When you start a virtual machine, you must associate that machine with a construct that we call a security group. Now, I'm going to explore them in a little bit more. I'm going to give you how you would link some of these together. Security group. A security group is a definition. Think of it as a semi-stateful firewall. It's a list of the traffic that's allowed into the box. So you give the rule, and you can have multiple rules in a group. You give the rule a name. You indicate the destination protocol and port number, and the source IP address or origin. Now, just park the word origin in your brain for a minute, because I'm going to define that momentarily. All right? And the default group is default deny. Right? You actually have to open up the security group, and then you associate that to an instance. Now, the code for the security groups that's part of our secret sauce, and that lives in the hypervisor. Right? So this is one of the things that helps to isolate VMs from each other. Now, like all responsible software companies, we do have a pretty stringent security development lifecycle. We do regular penetration testing for the code that we do, and we also rely on outside third parties as well to take a look at this. I feel really confident in this code. I don't know of any occasions of where there has actually been cross-VM communications. Because all of the datagrams that travel between VMs are actually associated with a particular customer ID as well. Right? And that is going to become important when I talk to you about how you can build virtual network tiers in an infrastructure where there are no separate virtual networks. So it is a pretty flat network that we have. But people are typically used to thinking in tiers, right? So how do you replicate what you're accustomed to doing in something that physically looks very, very different. So I wrote about this on the AWS blog several weeks ago, and the blog post was basically kind of what I'm going to tell you now. I use this diagram to show what a typical 3-tier requirement might look like. So the web tier, you allow traffic in from the internet. You also might allow management traffic from your CorpNet, right? You might want to RDP into the box. If it's a Windows box, you're probably going to have to do that if you want to log in and manage the thing. At the application tier, you're going to allow traffic to come in from the web tier. And at the database tier, you're going to allow traffic to come in from the application tier. Now, there's a number of ways that you could actually go about creating this. And one of them is you could use the AWS console. So we have a GUI console that exposes most of the functionality of AWS. And in this instance here, I've created the Web Application Security Group. And you can see that it allows inbound traffic from the internet, which is defined as 0000/0, to destination ports 80 and 443 TCP. I'm also allowing inbound traffic to destination 3389 from my CorpNet, and I invented that IP address range. Okay? Now, of course, somebody could try to spoof that IP address range. That's why you're going to rely on something like SSH or the RDP security features, so you actually have to log into a user account on the machine to manage it. I'll get to that, okay? Yeah. I tend to sort of bounce around because I like to put things in your brain and then come back to them. It's a bad habit, I know, but it's the way I do things. So here's the application security tier. All right, now take a look at that. You can see I've still got a line there that allows RDP traffic from the CorpNet, but note that the source is not a set of IP addresses, 0000, but is the named security group, right? So the only machines that can talk to the application tier are machines that live in the security group labeled WebSG. Now, what if somebody else has a security group also named WebSG? This is where your customer ID comes into play, right? Only your app SG, as defined by your customer ID, allows only your security groups to talk, right? So somebody else's WebSG won't come through this rule. Only your WebSG will come through this rule.
So by way of comparison, would it be fair to say that your customer ID as a tag and your rule name is really just functioning as a super rule?
Yeah, and it's part of what happens. In a minute, I'm going to actually show you the API calls. And I've left out an element in the API call because I just didn't have room to put on the PowerPoint. But when you are using things at the API, you actually have to sign every request so that we know that it's yours, right? It'll become a little bit clearer in a minute. I sort of like to do the graphical version first because I then need to tell you why you don't want to do it this way. Actually, I think I can probably tell you that right now. Yeah, take a look at the defined port range for the WebSG. Basically, at the GUI, when you use a security group as the origin, it opens it up for all ports on TCP, all ports on UDP, and all types for ICMP. Currently, right now today, the security group functionality in the console reflects the capabilities of an older version of the API. Now, this is for backward compatibility, okay? In a minute, I'm going to show you the better way to do this. But I just, in the spirit of transparency, I need to let you know how things happen right now. Here's the last one, the database group. And notice that, I'm opening it to two things, my CorpNet plus my database vendor. And then, like before, I'm allowing only the app security group to talk. Yes, sir?
Looks like with the list that it doesn't even allow traffic to in a group for the more machine side group, talking about machine side group.
Well, so if two machines are in the same security group, these rules still apply.
So there wouldn't be a problem.
No. The better way to do this is with the APIs. So we have a set of command line utilities that you could use. I'm a UI guy. I grew up in the Microsoft world. I love to point and click. But when it comes to defining security groups, I'm going to use the APIs because the APIs actually expose the current degree, I'll get to just a second, the current degree of functionality. And if you'll note there that using the APIs, when I'm defining the rules for the app security group, I can actually indicate the particular ports and protocols that we should listen on. So I can get a little bit more fine-grained. The plan is to bring the console up to parity with the current API. I don't know what the timeline is on that, but you know, I just want to make sure that you understand that for this particular thing, please install the command line tools and use the APIs to configure security groups. Yes? No. An instance cannot be attached to more than one security group at a time. And that is another thing, too. Once you start an instance and indicate what security group it belongs in, you can't change that. Right? If you need to change the security group that an instance is in, you actually have to terminate the instance and restart it and move it over.
Is there an implicit denial?
Yeah. Yes. Now, I want to introduce something to you. So in a couple of the talks before I came up here, people were talking about the notion of web application firewalls or doing some kind of inspection. Take a look. What's open to the internet right now? The web server, right? What if we add another tier? And for sake of better language and color, I use dark purple and black, and I call it the inspection tier. And I've named it the inspection security group. I think this is kind of an interesting concept. Instead of exposing the web servers directly to the internet, why don't you instead put them inside a security group that only allows inbound connections from an instance in which you've installed a web application firewall, or an IDS, or an IPS, or whatever you want, right? You've got complete freedom in how you structure these rules to interact with each other and build whatever level of tiers, whatever degree of traffic path that you want to do. And one of the things that's sort of on my list of things to do is actually sort of document how you can do this. There's a feature called Virtual Private Cloud that instead of creating instances that have internet access, they live behind an IPsec tunnel mode security association between a gateway on our side and a gateway on your side. And you have to define routing in your infrastructure that allows traffic on your CorpNet to talk to these instances. They don't have any internet access currently. Probably the most confusing thing to do is to remember to, in your network, write the return routes. I used to build VPNs for a living. I always left out the return routes. Could never figure out why my pings went but never came back. Just something to know. Here's where what you can do with VPC right now. It's still in beta. So things in VPC are only in one availability zone in either Virginia or Ireland. We don't have that everywhere yet, but it's planned. We are also looking at multiple AZs and multiple routers. I love this idea of multiple routers into a single VPC. Imagine someday when there's no central IT anymore. I know that all makes you get really frightened right when you hear about that. But think about a bunch of regional offices all with routers connecting to a single VPC, and everything's in a VPC, including your domain controllers. S3, our storage system, the most important thing I want to highlight your attention to is that when you put an ACL on a bucket, which is like a folder, the ACLs on those objects do not inherit. You actually have to define them on the objects themselves. It's not like normal operating systems are. So I said I wanted to talk about encryption for a minute. I'm going to do that right now.